Okay, good morning, guys. Today we're going to start learning 3-2 solving systems algebraically. Yesterday we learned how to solve systems graphically, and that has its value, that has its usefulness. I usually use graphing when they're really, really simple lines. Say easy numbers, no decimals, no y-intercepts that have fractions, nice, pretty equations. I like to solve by graphing. Once they start getting a little bit more difficult, I solve either by substitution or elimination. Okay, there are 3 total ways to solve a system: graphing, substitution, and elimination. So let's go ahead, and sometimes you may see in some books they call elimination the addition method, and it makes sense, but I like elimination. Okay, now what is the solution of the system of the equation? This is relatively easy. I could graph this and go ahead and be done with it, but they're not always going to be nice, pretty numbers. I use nice and pretty numbers just to teach the example, okay? But the numbers are going to get a lot uglier. There's going to be decimals. There's going to be fractions. It's not going to be this easy, but for teaching methods, I figured it would be better to teach you with numbers that were doable. First step, choose an equation and solve the variable of your choice. Try to choose the easiest one to solve for, okay? Try to choose the easiest one to solve for. I missed a... Okay. In this particular case, look at these guys. Which one would you solve for? Which is the easiest in this particular case to solve for? Thank you, bro. I would solve this equation for y. So y equals negative 2x plus 10. Does that make sense to everybody? Promise? This is real easy, but it takes steps. Substitute the expression for the variable you just solved for in the other equation. Solve for the other variable. Excuse me. I'm going to take the value of this y, right? And I'm going to plug it in to this. So I'm going to have 3x plus 4 times y, which equals negative 2x plus 10 equals 12. Everyone see what I just did? I took the value of the variable that I just solved for and I plugged it in the other equation, into the other equation. Does that make sense, guys? Guys? Okay. Now, solve for the other variable. Okay, so now let's solve for x. Excuse me. All right. Now, okay, so I got 3x minus 8x plus 40 equals 12. Negative 5x equals negative 28, guys. Is that right? And then divide by negative 5, divide by negative 5. So x is going to equal 5. No, positive. Negative divided by negative is a positive. Thank you, my brother. But it is, you're absolutely right, 5.6, okay? See, would that have been pretty to graph? These equations were easy. You could have graphed them both, but that's going to be nasty. See the beauty of this? Now, step 3. Substitute the expression for the variable you just solved for in the other equation. Solve for the other variable. Go back to either one of the equations if you want, but I'm going to go to the easy one. Didn't we say that y equals negative 2 times x, which in this case is 5.6 plus 10? Do you see what I just did there, guys? So now y is going to equal negative 11.2. Is that right? Yeah, negative 11.2 plus 10. So y equals negative 1.2. So my solution, 5.6, comma, negative 1.2. I don't care how good of a grapher we are, we never get that exact answer. That's why we use substitution and elimination. Does that make sense, guys? Let's just run through it right quick, real quick. First, you choose, I'm just going to erase some of this to make it easier to understand what we're doing. 1, choose an equation and solve for the variable of your choice. Try to choose the easiest one to solve for. We said, okay, this looks pretty good. we're going to solve for y. And we did. We said that y was equal to negative 2x plus 10. Then we said, okay, now that we know what y is, we're going to plug that right into this y right here because y equals y. So that's what we did here. And then we solved for x. Then I plugged that x right back into the x. I went over here with that. And that's my answer. Does that make sense, my brothers? Okay, next, elimination. I like elimination a lot better. Me, personally. We'll go over when to use what, but I like elimination. First thing, line up the equations, variable to variable, and add the equations together, making sure that one of the variables is eliminated. You're going to put this basically into standard form. Okay. The reason why they call it the addition method sometimes is because you are going to add these two together. Now, sometimes they're going to have it very nice and pretty, like it is right here. This is very, very, very pretty, very nice. They're lined up, x to x, y to y. I'm going to add them together. 4x minus 4x, that's 0, that cancels, plus 5y equals 25. Divide by 5 to both sides, y equals 5. Step 1 is complete. Step 2, substitute the value of the variable you just solved for in either of the given equations and solve for the other variable. So now I know that y is 5, right? So I go to either variable. I really don't care. Me personally, I'm going to choose the first one. So 4x plus 2 times y, which is 5, equals 9. So 4x plus 10 equals 9. So 4x equals negative 1. So x equals negative 1/4. So my solution here would have been negative 1/4, comma 5. And you can plug these in to check. 4, okay, over here, 4 times negative 1/4 is negative 1. Plus 2 times 5 is 10. Negative 1 plus 10 is 9, and it works. Does that make sense, guys? Okay. So, yes, sir. Thank you. I'm sorry, my man? That's exactly right. That's what I got right here. That's exactly right. Good job, son. Negative 1/4, comma 5. Yes, sir. That's going to be the next one. That's going to be the next question. What Jimmy asks is, what happens when they're not set up so pretty like this? And I'm going to show you right now. You guys ready? Got it? Okay. Thank you. Now, what's the solution of this system? Okay. Sometimes you will have equations that do not eliminate easily, like here. 2x and 3x, okay. 7y and 5y, okay. Those aren't going to eliminate easily. In these cases, you need to line up the equation, just like always in standard form, and create an equivalent system by multiplying each side of one or both equations, depends on how difficult it is, in a system by the same non-zero number. Then you line up the equations, variable to variable, and add the equations together, making sure that one of the variables is eliminated, and then you substitute that value into the other equation and find the other variable. First things first, what do you guys want to get rid of? The y or the x? I don't care. And neither should you. It doesn't matter. The y? Okay. What's common between 7 and 5? I love this class. Great. It's 35. So let's make one of them positive 35 and the other one negative 35. Does it matter which one you make positive or negative? No. But one has to be positive, one has to be negative, because we want them to cancel, right, guys? So I'm going to multiply by, I'm going to do negative 5 here if that's okay with you guys. And then here, I'm going to go by 7, if that's okay with you guys. Does that make sense? Guys, I see some of you a little lost. Okay, now distribute. Negative 10x minus 35, y equals negative 20, plus 21x plus 35y equals negative 35. The y's canceled, bye-bye. 11x equals negative 55. x equals negative 5. Not so bad for what seems to be very complicated, huh? Now that we have that x is negative 5, what do we do, my brothers? We plug it in. Do I have to plug it into one particular equation? No. Either of the originals will work, gentlemen. Either of the originals will work. So I'm going to choose this time the second one, just because I want to. 3 times negative 5 plus 5y equals negative 5. This is negative 15 plus 5y equals negative 5. You're going to add 15 to both sides. 5y equals 10. Sorry, let me extend the screen. Divide by 5. Y equals 2. So my solution is negative 5, comma 2. Does that make sense? Now in this case, you have to multiply to both of them. Sometimes it'll be easier. You don't have to multiply to both of them. You just got to multiply to one of them. Okay? Just got to show you 2 more little special cases, and we're golden. We good? All right. Thank you. All right. Now let's do an application. Yay, your favorite. All right, I know some of you know. Okay, look. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee of materials, including books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? Okay. So, 6 lessons cost $300. 12 lessons cost $480. Okay. So let's see how we set this up. What are the variables that we're dealing with here? What are the variables that we're dealing with here, guys? We have 2 different variables. What's it? Not the number, but we're talking about the cost of lessons. Right? We're talking about the cost of lessons, and we're also talking about the one-time fee. So I'm going to call the cost of lessons C, and I'm going to call the one-time fee F. You want to call it X and Y? Whatever. Doesn't matter. You with me so far? Okay. Now, when you buy a new piano, you get the 6 lessons, okay? Plus all the stuff, the music, the software, CD, and the one-time fee included. So what you have is 6 times the cost of the lessons plus the one-time fee equals $300. Or 12 times C, the cost of each lesson, plus the one-time fee equals $480. Now at this point, let's use elimination and let's solve. I'm going to multiply everything here by -2 because I'm going to get rid of the x's because that's the easiest thing to get rid of, okay? I'm going to rewrite this equation down here. So it's going to be -12c minus 2f equals -600. C's cancel. -f equals -120. So F, the one-time fee, is $120, guys. Bam. Says what does it cost for each lesson and the one-time. So we got the one-time fee. Now how do we find the cost? Plug it back in. Thank you for whoever said that. So I have 6C plus 120 equals 300 minus 120 minus 120. 6C equals 180 divided by 6. C equals $30. So the cost of one lesson is $30 and the one-time fee is $120. Does that make sense, guys? Okay. And for these, just look at it real quick. Real quick. I know the bell's about to ring. I just don't want you to get surprised. When we're eliminating this, look what we get. 0, that cancels, that cancels. So I get 0 equals 0. Is that a true statement? Just like before, 0 does equal 0. So when it's a true statement, it's, and I'm going to show you a new symbol for that. That means all real numbers. You can use that. And then this one, boom, boom. Does 0 equal 10? That's a false, so that's no solution. Or you could give me this symbol. We finished right at the bell. Homework is valid. Don't forget your prep works, my brothers. God bless you all. Thank you for a great, great class.